Hello friends, once again we begin with syllabus of electronics in which we have to study the chapter of power supplies, that is second chapter in case of electronics 1. So in the previous lecture we already explained the block diagram of power supply, or what are the different blocks that will be required by the power supply, and there is a particular functions of each block. For example, we have the transformer, then rectifier, then filter, then regulator. So there are a number of blocks in case of power supply. So that we have already learned in the previous lecture. Now we have we have also discussed the concept of half wave rectifier in case of the rectifiers. Already we have the understanding of rectifier, a circuit which converts the AC into DC, AC voltage or current into DC voltage or current. So that circuit is called rectifier, and in that we already discussed the half wave rectifier and full wave rectifier. Okay. Now we have the next important circuit. Again, it is the category of full wave rectifier, but compared to the full wave rectifier, it has four diodes, and that is the circuit is called a bridge rectifier. So already we know the meaning of bridge here. So there's a combination of four resistors, and that will form the bridge like this. So how to draw the diagram or technique of drawing diagram here we are going to understand here. Check carefully. So here we have the AC mains. So here we have AC main supply. Then we have the primary coil of transformer. Then core of the transformer. Then we have the secondary coil of transformer. And then we have the combination of four diodes here. Check carefully the diagram here. So it will begin with the four diodes. Suppose if you begin with this point, so there are 4 points we have to mark like this. Check carefully. So the first diode is, if you draw, this is first diode. Second diode again in the same direction, like this. Next diode, third. And the fourth diode. So check carefully the direction of diode from left to right direction. Diode P type, N type, P type, N type, P type, N, P, N, like this. Now the secondary is connected to the two terminals, like this. First and second terminal. And output is taken across the opposite points. So here we have taken the output like this. Here we have the load resistance RL. So across which we have the potential V. So potential V is across the load resistance. Suppose if we number the diodes, so we have the number system according to textbook here, suppose. Or you can number any, suppose diode D1, then diode D2, then D3, and D4 like this. Okay, so this is general diagram of the bridge wave rectifier. So from AC mains we have transformer. Transformer reduce the voltage from 230 to desired value, for example 12 volt, 24 volt AC. Now that AC with the help of four diodes, that combination is called bridge. So this bridge circuit has four diodes, and with the help of that four diodes we convert AC into DC. across the load resistance. So this is diagram of bridge wave rectifier, potential developed across, suppose the minus and suppose the positive like this. So for DC we have positive and negative terminal, that is potential V across the load resistance. Okay. Now check carefully what we have to write down and what are the different points for the understanding. Check carefully. So what are the different points or the working of bridge wave rectifier? Check carefully the presentation. Okay. Now check carefully. We have the diagram of bridge rectifier. So it will be look like this. Already we have drawn the diagram. So AC input, then we have the transformer primary coil, that is core. Then here we have the secondary coil. First terminal of secondary goes to this point where we have the two diodes D1 and D2. Then second terminal of secondary coil connected to the again two diodes like this D4 and D3 for example. And load resistance is connected across these two terminals. And the potential DC potential VO obtained across the load resistance RL. Okay, so this is construction of bridge rectifier. Now how the working will be there, that we are going to understood here first. Now check carefully. We know that when there is a positive half cycle at one terminal of secondary, suppose here we have the positive half cycle. Check carefully the diagram. Already we have drawn the diagram or practice of drawing diagram also. How to draw diagram, what are the techniques, what is the polarity of the diodes. So that all these things we have already learned. Now how to understood the simple working, so that we will understood here. Check carefully the understanding of working here. So if here we have the positive half cycle, the other terminal is negative half cycle. So there is a when there is a positive half cycle at one terminal, negative half cycle at the terminal. So what happens when positive half cycle reach at this point? Now there are two diodes, D1 and D2 here. So when there is a positive half cycle, that is positive voltage increases, D2 will be in forward bias and D1 reverse bias. Okay. Similarly, when negative half cycle at this particular point, so this will be D4 is in forward bias, D3 will be in reverse bias. And accordingly, the current will be flow, check carefully, from D2, RL and D4 like this. So circuit will be complete like this in case of positive half cycle. So that we have already explained. Check carefully what we have the explanation. It require four diodes. So already we have drawn the four diodes, but center tap transformer is not necessary. So center tap transformer is not necessary. Check carefully, we have the diagram of center tap transformer in case of full wave rectifiers here, one terminal, second and third. So it requires three terminals, three terminal transformer. But in case of the bridge rectifier, only we require ordinary transformer which has two terminals. Okay. Now next second point is important. Check carefully the positive half cycle of secondary voltage. Check carefully positive half cycle of the secondary voltage D2 and D4 conducts the diode. D1 and D3 do not conduct, and accordingly the current flow through the secondary winding D2 RL and D4. So that already we have explained in the diagram. Check carefully. Positive half cycle means positive voltage goes on increasing, and accordingly D1 reverse, D2 forward. That current will be flow through D2 load resistance, and here we have the positive cycle or positive half cycle will flow through this or current flow through this. So this will be positive, and compared to here we have negative. So current flow through D4 in this direction and complete the loop like this. Okay, so this is the first or positive half cycle, and similarly we have number third during negative half cycle of secondary voltage. Now for here we have suppose negative voltage. So negative voltage half cycle at the D2 and D1, and corresponding positive half cycle at D3, D4. So we have the working from D3 and D4. Suppose here we have positive half cycle. So positive half cycle goes on increasing for these two diodes. So this diode will be reverse bias, D3 will be in forward bias. So current will flow in this direction. So positive voltage goes on increasing, that is connected to P type, and the current flow through the diode D3 through the load resistance and then D1 and complete the path like this. So here we have simple D3 and D1 will be conducts, D2 and D4 will be doesn't conducts. So during the negative half cycle, the secondary voltage D1 and D3 conducts, and D2 and D4 do not conduct. The current flow through the secondary winding D1, RL and D3. So this is the working of the full wave rectifier or bridge wave rectifier, which is also a category of full wave rectifier. So check carefully the second diagram here. Waveform we obtain like this: positive half cycle, we have positive half cycle; negative half cycle, we again obtain positive half cycle. So the waveform is nearly same or exactly same as compared to the center tap full wave rectifier. Okay, now we have some definitions or the terms. Check carefully. In both half cycle, current pass through the load resistance in same direction. So average voltage VDC is equal to 0.63636 times Vm, which is calculation is 2 times Vm divided by pi. So this is the average DC voltage obtained across the load resistance. So we have simple formula, twice Vm divided by pi, where Vm is a peak value of secondary voltage here. Now similarly, the next current rating of diode, each diode conduct only half cycle. Therefore, current rating I0 of the diode must be at least half of the DC load current, 0.5 times IDC. So I0 current rating is exactly half because the DC current divided into two parts. So the diode rating must be half of the DC here. So we have 4 diodes, and at a time 2 diodes will be conduct, 2 diodes will be doesn't conduct. So current will be divided into two parts. So 0.5 times DC here. So that is the current rating of diode. Okay. Now we have next term, peak inverse voltage, PIV. So in bridge rectifier, each diode must withstand a peak inverse voltage equal to peak secondary voltage, that is PIV is equal to Vm. So this will be less than the full wave rectifier. Check carefully. We have PIV is equal to 2 times Vm in case of the full wave rectifier. And compared to that, we have here PIV is only Vm, because the Vm will be divided across 2 diodes and peak inverse voltage will be Vm. Therefore, PIV rating of the diode must be greater than Vm. And one more thing, the ripple frequency is the double the input frequency, that is also same as the full wave rectifier. The maximum efficiency of bridge rectifier is 81.2%. Means the efficiency means AC is converted to DC has efficiency near about 81.2%. Okay. Now we have some advantage or merits of bridge wave rectifier or bridge rectifier over full wave rectifier using center tap transformer. So what are the merits here? The center tap secondary winding is not necessary. So center tap secondary winding means such type of transformer is not required, which require three terminals, one center tap and two of the secondary winding. So such type of transformer is not required in case of bridge rectifier. Now number second, if stepping up or stepping down voltage is not necessary, bridge rectifier may be constructed without with using any transformer. So we can have the any transformer can be useful for designing the bridge rectifier, and this condition is not required here. Okay, so number next is PIV. That is already we have explained. PIV of each diode is equal to peak secondary voltage Vm. But in case of for full wave rectifier using center tap transformer, PIV of the non-conducting diode is 2 times Vm. So these PIVs differ here. So therefore, transformer and diodes in that type are costlier. So costly transformer as well as diode is required in case of the full wave rectifier using center tap transformer. Okay. So this is the PIV rating. Sorry, this is the merits 1, 2, and 3. These are the merits, and now we have demerits. In bridge rectifier, 4 diodes are necessary, but in case of ordinary full wave rectifier using center tap, 2 diodes are required. Number second, when low DC voltage are required, when low DC voltage required, 2 diode voltage drops. So the voltage across drop across 2 diodes, 0.6 volt in case of GE diode and 1.4 volt in case of silicon diode becomes significant. So in case of bridge rectifier, voltage will drop across 2 diodes, and because of which low DC voltage, what we have the, if these voltage drop are compensated by selecting a transformer with a slight higher secondary voltage, the voltage regulation becomes poor. So this will be the poor regulation is obtained because of the drop across 2 diodes in case of bridge rectifier. So these are the demerits. Just we consider the bridge rectifier require 4 diodes, which is in case of full wave rectifier only 2. And here we have for low DC voltages. So when low DC voltage are required, 2 diode voltage drop 0.6 in case of GE, that is across single, and 1.4 volt in case of silicon diodes, 2 diodes 0.3 plus 0.3, 0.6 volt if in case of germanium diode, and 0.7 plus 0.7, 1.4 volt. So that will be across or remain across the diode. So that doesn't convert it into AC to DC here. So that is one type of drawback in case of the bridge wave rectifier compared to the ordinary full wave rectifier using center. So these are the demerits. Now we have the important topic or the next topic or next block of the power supply. So we have discussed here the first block as the rectifiers in case of our block diagram of power supply. Check carefully. We have very first diagram, AC mains, then transformer. So transformer already we have learned in previous standard, and very first block in case of this chapter is rectifier. So we discussed the rectifier topic. We have 3 types of rectifier: half, full, and bridge rectifier. Now we go to the next topic, that is called filters. So check carefully what is the general definition or meaning of filter here. Check carefully. Ideally, direct current is unidirectional and steady. So DC current will be in one direction and steady. Suppose we have ordinary battery or cell, and when we connect any device, suppose we have a light bulb or LED across that particular cell, the current will be directly flow in one direction without fluctuation. So unidirectional and steady current will flow. But the output of rectifier is not steady. Why the output is not steady? Because it is fluctuating. positive half cycle 0, positive half cycle 0, positive half cycle 0. So like that we have the output of rectifier. That output we have to convert into the smooth or without fluctuation. So it is unidirection but fluctuates greatly with time. It has an average or DC value over which number of AC components of different frequencies are superimposed. So we obtain DC in case of rectifier, but it is fluctuating. So we have some AC component in DC here. So that we have to reduce. This frequency, AC frequency are superimposed. AC component of different frequencies are superimposed in DC. These undesired AC components are called as ripple. So what do you mean by ripple here? So ripple is the AC component in the DC of rectifier. So rectifier convert AC to DC, but it is not smooth DC. It has the positive value, positive peak value 0, positive peak value 0. So gradually increase and decrease, and that is called AC component. And that components are called ripples. Now we have to reduce that ripples here using the filter circuit. Now check carefully. For half wave rectifier, lowest ripple frequency is equal to the input frequency. But for full wave rectifier, lowest ripple frequency is twice the input frequency. So that already we have learned. Now what is actually role of filter is we have some definition also. A ripple means what? A ripple frequency means what? Ripple factor means what? So check carefully. We have the detailed understanding, and then we go to the filter circuits. So what is the general definition of meaning of ripple factor? RMS value of AC component divided by average or DC value. So RMS value of AC component divided by average or DC value. So how much RMS value of AC, that is in the DC or rectified output. Rectifier output has both component AC and DC. So RMS value, root mean square value of AC component divided by average or DC value. So these will obtain ripple factor, and ideally we calculate ripple factor should be very small, and we have calculation R is equal to under root of I RMS divided by I DC square bracket square minus 1. So this is calculation of I RMS, root mean square value of AC component, and here we have the average DC voltage, and this will be the average ripple factor. Now we have the general calculated value. For half wave rectifier, ripple factor is 1.21, and for full wave rectifier it is 0.482. So ripple is less in case of full wave rectifier compared to half wave rectifier. And we have one more formula. Percentage ripple is equal to ripple factor. This is ripple factor into 100 here. So we obtain percentage. Suppose we have 121% or 48.2% in case of the full wave and half wave rectifier. Half wave has 121 and full wave has 48.2, like this. Now we have rectification efficiency. So what is efficiency of rectification? Means how much AC is converted into DC, that is called efficiency. So we have the efficiency depend upon the DC power delivered to the load. How much DC power delivered to load, and divide by AC input power from transformer. How much power we have used from the secondary of transformer, and how much power is converted into DC, and that DC is delivered to the load. So DC power delivered to load divided by AC input power from transformer secondary. So that is called rectification efficiency. So these are the definitions given in your textbook, and accordingly we have the questions in examination. So maximum rectification efficiency is 40.6 for half wave rectifier and 81.2 for full wave rectifier. So this is the efficiency number we have given like this. Okay. Now check carefully. We have the first or the general definition of filter, and then we have the 4 types of filter circuits. So check carefully. The circuit used to remove AC component from output voltage so that steady DC output voltage is obtained is called filter circuit. What we have to remove here, the fluctuations of AC that we have to remove, and with we remove the fluctuations, we require smooth DC voltage, and that is the role of filter circuit here. And we have the number of filter circuits, and there are four types we have to discuss. A smoothing filter is connected between a rectifier and the load. So filter circuit is connected in between rectifier output and the load. Between rectifier and load, we have to connect the filter circuit. And what are the types of filters? We have the four basic types of filter, as for example, capacitor filter, inductor filter, LC filter, and RC filter. Okay. Now let us begin with number first. So very simple circuit. Just we have to understood the working of the different types of filters here. Circuit is very easy, and for that also we require certain basic knowledge of capacitor, inductor, and their particular working, or what is the particular function of capacitor in case of AC circuits as well as DC circuits. So that we will also explain here. So check carefully diagram AC input. Now this block already we have learned as a half wave rectifier, full wave rectifier, bridge rectifier. So that is in the square box here, or rectifier block. So this is output of rectifier. We have the capacitor filter. So we connect the capacitor, and generally we connect the electrolytic capacitor, which has positive and negative. So electrolytic capacitor positive terminal and negative terminal according to the output voltage, and we have load resistance RL, and here we obtain the output DC voltage, which will be filtered output here, and corresponding diagram. So diagram or waveform we will understood later on. So before that, what we have the understanding of role of capacitor in case of the filter circuit, that we have to understand. Check carefully what are the points we have to consider in case of capacitor filter. Now check carefully. So already you have learned the concept of capacitor in previous standard, that is electronic components. So capacitor C act as open circuit for DC. Check carefully. Capacitor act as open circuit for DC. Why it is open circuit? So check carefully. We have suppose capacitor plates, first plate and negative, positive plate and negative plate. Suppose we have two plates, one terminal connected to positive, second negative. What happens when we apply positive plus or minus voltage or DC voltage? Capacitor get charged. After charging, no current will be flow through the capacitor, or there is a separation between positive one plate and second plate. So one plate become positively charged, second plate become negatively charged. After charging, no current flow through the wire like this. So because of which we have the first sentence, capacitor C act as open circuit for DC. So as capacitor is charged fully, no current will be flow through any of the circuit, and provide low reactance. Check carefully, reactance path for AC component of the current. Low reactance path for AC component of the current here. So this is one of the important part. Check carefully, reactance path for AC component of the current. So what is general meaning of reactance? So again we have to check the syllabus of 11th standard. So in 11th standard we have the capacitive reactance and inductive reactance. So resistance offered by capacitor to the flow of AC. Check carefully what is the definition here. So the reactance means what? Opposition to the flow of AC. So here we have low reactance path for AC component. What is formula for the capacitive reactance? Xc is equal to 1 upon 2 pi Fc. F is the frequency of AC and C is the capacitance value. And 1 upon this value is very low. So because of Xc is very small, so it is called low reactance. So if it is low reactance, then what happens in case of circuit? Check carefully. So positive and negative, positive potential, negative potential, capacitor is charged, then no DC will be flow through capacitor. Capacitor is the insulator. The plates are separate from each other, so no DC value will flow. But for AC, AC will be fluctuating, positive, negative. So that will be AC will be flow through capacitor and grounded here. No AC will be flow toward the load resistance. So AC will be flow through capacitor as it has low reactance. Reactance means resistance in short. So low resistance path for AC component of current, and this is the formula for reactance or capacitive reactance. Now check carefully number third. The DC pass only through the load and produces DC output voltage. AC get bypass to the ground through C. AC will be bypassed through C and is grounded here. So AC doesn't flow through the RL, but it is grounded or bypassed through the capacitor. Okay, so this is the point number third. Now check carefully number four. Remaining small part of AC component passes through RL and produces a small ripple voltage. Small portion pass through the RL and produces small ripple voltage, and the ripple may be decreases by increasing C or RL. So ripple we have to increase. Ripple means fluctuation can be increased, decreased by increasing value of C. Capacitance value have to increase, as well as the load resistance we have to increase, or we have to increase both the values. This causes increase in DC output voltage. In practice, the capacitor is of electrolytic type. So already we have explained why we have taken electrolytic. It has the positive and negative, no reverse direction current will flow the through the electrolytic capacitor, as it has the separate positive and negative terminal here. Okay, now we have the important part. Check carefully. So if it is not a filter circuit, without filter circuit, only rectifier output. So rectifier output is dotted line like this. Check. So this dot line represent the rectifier output. But with the help of filter or filter capacitor, the voltage will be, the capacitor is charged. So this will be point A. Then we'll go to the B. Then again C. Doesn't become zero because charging and discharging of capacitor. So we obtain the waveform like this, A, B, C, D, like this. And we have the VDC like this. So the DC voltage doesn't become zero, but has certain minimum value and maximum value. And in between them, the value of DC will fluctuates. So this is the role of the filter circuit here. So that explanation we have to consider for the understanding of capacitor circuit. Okay. So check carefully. Instead of 0 to maximum, 0 maximum, 0, the DC value will be fluctuate, or the fluctuations will be minimized using the capacitor circuit. So this will be average DC will be obtained VDC in the waveform here. Now similar thing will be observed in case of inductor also. So before that we should know the general idea of inductor, what is the role of inductor in the circuit or AC and DC circuits. Now check carefully. So again we have the simple circuit, AC input, rectifier and inductor. Now inductor L is always connected in series. Capacitor is connected in parallel, but here inductor L is connected in series with the load resistance RL. So we have inductor. Inductor means one type of coil here, which has certain inductance. So already we have explained the concept of inductor and inductance in standard 11th. So one type of coil, and that has the property of the opposition to the flow of AC. Once again check carefully, property of opposition to the flow of AC, and that is according to self-inductance. The concept of self-inductance and mutual inductance, and that is according to Faraday's law of electromagnetic induction. So that concept we have to once again learn in physics also, in a chapter of electromagnetic induction, and in that chapter we have the first law is called Faraday's law of electromagnetic induction. Then it has first law, second law, Lenz's law, and then we have the concept of self-inductance and mutual inductance. Based on mutual inductance, we have the construction of transformer, and in that topic we learn how the working of inductor in case of AC and DC circuits. Okay. So rectifier output. So here we have the series inductor and load resistance, and across the load resistance we have output voltage DC. Now later on we explain the waveform here. So what we have the given, check carefully. The inductor filter consists of choke, ion core inductor. Choke is another word for inductor, which has the ion core. Ion core means what? We have the number of ion strips that will be connected together, but it is insulated from each other, and that strips you have to join one by one, side by side, and there is a separation, or there is a insulator between the two plates, and that bunch of plates we have to have the winding, or copper winding is wound on that particular bunch of the ion plates, and that arrangement is called ion core inductor. So a wire is wound on ion core, and that is called choke here, in series with the load. So this choke is called inductor or inductor filter. Now inductive reactance, we have the similar to the capacitive reactance. XL is equal to 2 pi FL. So L is the coefficient of self-inductance, F is frequency, and 2 pi is directly proportional to the frequency. So here XL directly proportional to F. 2 pi remain constant, L also remains constant. So it opposes any change of current to it. Okay. So this will be the general idea of the circuit. Now check carefully how this particular inductor work as a filter. Now check carefully. Thus, when a choke of inductor L and a small DC resistance is connected in series with a load resistance RL, it will offer high reactance to the AC component, a small resistance to DC component. So here we have the concept of the reactance. Reactance is similar to the resistance, but reactance is used when we have the AC. Now check carefully. This third point is very important that we have to write down in a case of examination. So teachers check the third points. Paper checker check the third point in case of description here, in case of inductor filter. So when choke of inductance L and a small DC resistance, that wire has certain small DC resistance is connected in series with the load RL. It will offer, what it will offer, high reactance means high opposition to the AC component. AC component blocked by inductor, and small resistance to the DC component. Small resistance to the DC component. And accordingly, AC blocked by inductor, DC flow through the inductor. So the ripple factor decrease when RL is decrease and L is increases. So this is the understanding here. Check carefully. Inductor block the AC component, pass the DC component, and accordingly we have the waveform. Initial waveform is like this: 0 to maximum, 0, maximum, 0. But with the help of inductor, we will obtain like this, the waveform filter output like this. So this is the waveform of the output voltage with the help of inductor, as inductor block the AC and pass the DC like this. Now in the next lecture, we begin with the third type of inductor, that is LC filter here. Okay. So till then you note down the notes or the shortcuts or the corresponding diagrams. Practice the diagram at home. Try to draw diagrams 2-3 times. And what we have to write down in examination, that points you have to note down and prepare yourself for examination. Okay, so in next lecture we begin with the third filter, that is LC filter. Okay.